Alright guys, this is an example of a one proportion Z-test. Politicians claim that 40% of Republicans are female. So right off the bat, they're giving you the true proportion that they believe to be true. So P equals 0.4. Researchers take a random sample of 50 Republicans, find that 29 are female. Are the politicians' claims true? Test an appropriate hypothesis, state your conclusion. Number one is intro. We are testing to see if the politicians' claim that 40% of Republicans are female is true. So you would write that here. I'm not going to waste time doing that. On the AP exam, they definitely want to see an intro of what you're getting into. So the next thing then is we want to do our null and alternative hypothesis. This is a one proportion Z-test for a couple different reasons. Number one, it's categorical data. Female or not female would be categorical data. And in particular, it's a success or fail. A success would be considered a female. So we're dealing with proportions. So we know it's proportions. We only have one sample, so we have one proportion. And it's a Z-test because we know the true proportion. Also, we can estimate or actually find standard deviation in this case by taking the square root of P times Q over N. So we can find the standard deviation and therefore the population standard deviation, and therefore this is a Z-test. So this one in particular would be 0.4 times 0.6 is Q over N. And that's our particular N is going to be 50 Republicans. So let me bring this up. 0.4 times 0.6 divided by 50. And we want the square root of that. So that gives us 0.069 for that standard deviation. Alright, so intro again, we're interested in testing this claim that that politicians make about female Republicans. Null hypothesis is about the true population proportion, meaning the true population proportion of female Republicans is 0.4. Alternative is that in this case it's a two-tailed, so it's not 0.4. So the true population proportion is not 0.4. True population proportion of female Republicans. Next thing we need to do is conditions. I'm just going to list them here again. You gotta make sure that these are in context. So number one, are they independent? We would have to assume that they took a random sample. So the Republicans sampled are assumed to be independent. Number two, were they randomly selected? It says random up there. Again, give a statement. So Republicans sampled were randomly selected. Number three, do we have less than 10% of the population? Again, we only sampled 50 of them, so 50 is less than 10% of the population. You would write that here. So that's good there. And the last one is N times P. Can we expect to get more than 5 people? I'm sorry, 10. More than 10 people. More than 10 people. N times P in this case, N is 50, P is 0.4. Is we would expect to get 20. So that's good. Alright, so we can proceed with our one proportion Z-test. We're going to go to the calculator. Stat over to tests. Oops, I missed. One prop ZTest is option 5. Enter the info. What is the true population proportion? Well, they claim it is 0.4. We have 29 out of 50, which seems like it's significant enough, and we want to test that it is, we want a two-tailed test, so that's the option we're going to choose. Go through and calculate. Under the calculation, we have a Z statistic of 2.598 and a p-value that's pretty low, 0.009. So with a Z statistic of 2.598 and p-value of 0.009, in this case we would reject the null hypothesis. Oops. And finally we would say the true proportion of female Republicans is not 40%. Next thing we want to look at is a one proportion Z interval. Same scenario. Under a Z interval, anytime you calculate a Z interval, the only reason you're doing so is to estimate the true proportion. So you're estimating P, therefore you wouldn't be given the information of a true population proportion. All you're going to be given is, hey, researchers go out and take a sample, 50 people, 29 are female, and it would be find a 95% confidence interval for the true proportion of female Republicans. So what we're doing is estimating the true proportion based on what we've found here. All right, if you remember, confidence intervals are going to be centered around whatever your sample proportion is, so your p hat, and we're going to go up and down a certain amount. In this particular case, we're going to go up the amount that's specified by Z star, so the critical value here, times the standard error of our p hats. All right, we already calculated the standard error of the p hats on the last one. So that's going to be the square root of p hat times q hat. Over whatever our sample size is. Our p hat is 0.58, q hat is 0.42 over 50. That's calculated over here. So our standard error of the p hat is going to be 0.58 times 0.42 divided by 50. And we're going to take the square root of that. So that's going to be 0.06, what was it? 98. So there's our standard error. Z star is determined by inverse norm of however much area we want. And if you need to do a sketch, do a sketch. We have a 95% confidence interval, so that alpha value is going to be split between the two things here. So we want inverse norm of 0.025. Come up here. Distribution, inverse norm. We want 0.025. So that's going to be negative 1.95 or negative 1.96, or just 1.96 on the other side. So our p hat is 0.58. We're going to go up 1.96 times the standard error of p is 0.0698. So calculate those values and you'll come up with an interval of 0.7168 and 0.4431. And our statement at the end, we are 95% confident that the true population proportion of female Republicans is between those two values, so 71.68% and 44.31%.